Hello friends, once again welcome for the session 4 of frequency domain analysis from module 4 of control engineering for 7th semester mechanical. Let us take further examples to understand the polar plot in depth. We can have some another two examples. So here, sketch the polar plot for the following transfer function, that is g of s into h of s, that is equal to 1 plus s divided by s. So here, note down the transfer function carefully, that is g of s into h of s, that is 1 plus s divided by s. Identify the system type number and order number. Type number is 1 because the independent s term in the denominator is only one s term, hence its power is 1. So in this example, the power of s in the denominator contributes towards the s same number, that is 1 for type number as well as order number, because the order is also identified by the highest power of denominator of polynomial of s in the s system transfer function denominator. So here both type number order numbers are same, and replace s by s j omega in the above transfer function and adjust to s 1 plus st form if necessary. So here in this example, the transfer function, the numerator 1 plus s, which is already in the 1 plus st form, so independent s term you can write 0 plus s like that. So here replace s by j omega, that is g of j omega into h of j omega, that is equal to 1 plus j omega, that is 1 plus s, instead of s you are writing j omega, that is whole divided by only one s term is there, that is 0 plus j omega. Similarly, step number 3, find out the magnitude ratio as well as the phase angle. First let us see how to get the magnitude ratio, that is by using equation m omega equal to s real square of numerator plus imaginary square of numerator to the power 1 by 2 whole divided by real square of denominator plus imaginary square of denominator to the power 1 by 2. So here m omega equal to 1 square plus omega square to the power 1 by 2 whole divided by 0 square plus omega square to the power 1 by 2. So here finally further simplify m omega, that is magnitude ratio 1 plus omega square to the power 1 by 2 whole divided by, that is yes only omega, not omega square, because omega square to the power 1 by 2 means it is omega. Please make some correction here, that is here, that is omega square I have taken, this is only omega, because omega square to the power 1 by 2 means only omega. Please make that correction, that is called equation number 1. Phase angle is given by phi omega equals to tan inverse of imaginary by real of numerator minus tan inverse of imaginary by real of denominator. So here phi omega equal to tan inverse of omega by 1 minus tan inverse of omega by 0, that is for the numerator. Further simplify, tan inverse of omega by 1 is nothing but omega minus tan inverse of omega by 0, that is infinity. So finally tan inverse of omega as it is, tan inverse of infinity is minus 90. So this magnitude ratio call equation number 1, this you can call equation number 2. Okay, next substitute the limiting values of s omega. Yes, putting the limiting values of omega separately as 0 and infinity. So as s omega tends to 0, m omega is infinity and phi omega is minus 90. As omega tends to infinity, m omega is 1 and phi omega is, that is 0. Tan inverse of infinity is 90, this is minus 90, 0. And m omega is root 2, that is 1.414, phi omega is minus 45. So with these 3 points you can draw the the polar plot. So taking suitable scale, locate the points using polar coordinate system. Draw the smooth curve passing through these points. Okay. So here, yes, omega tends to 0, m omega is yes, it is 1. And omega tends to infinity, m omega that is infinity. As omega tends to 1, m omega is root 2. So by these 3 points, 1, 2 and 3, you can draw the yes, a smooth curve of this polar plot. Okay. Okay, let us take another example, that is example number 6. What is this one here? Sketch the polar plot for the following transfer function, that is g of s into h of s, that is equal to 10 divided by s into s plus 2 into s plus 5. Just see this time there are 3 s term in the s denominator, hence the order of the system is s to the power 3, that is 3. Okay, whatever system type number, that is 1. The independent s term in the denominator is only one s term, that power is 1. Okay, this time it is little bit tricky. 10 divided by s into s plus 2 s plus 5, and hence obtain the frequency and magnitude ratio where the curve crosses the negative real axis. So there also you have to find out the frequency where exactly the curve crosses the negative real axis. Let us see given data. The transfer function is given by g of s into h of s, that is equal to 10. Now done the same transfer function, 10 divided by s into s plus 2 into s plus 5. Identify the system type number and order number. As the type number is 1 because the independent s term in the denominator is, the power is 1, and the order number is 3 because the polynomial of s in the denominator is 3, the s power is 3, hence order number is 3. Let us see how the type number is 1, order number is 3, how the polar plot looks like. Okay. So once again, as usual procedure, replace the s by j omega in the above transfer function and adjust the term to 1 plus st form if necessary. So in the denominator you have to adjust to 1 plus st form because s plus something is there, that constant term you take outside, take common. Let us see. So here adjusting to 1 plus st form, that is g of s and h of s, that is equal to 10 divided by s into 2. Please see here, this is s into 2, not the s square, it is s into 2. Why it is 2? 2 we have taken outside common, that is, what is that one? 2 plus s is there, no? That 2 we have taken outside, so here 1 plus s by 2. Similarly here 5 plus s, so we have taken the 5 outside, that is 1 plus s by 5. Why you have to take outside? Because it should be 1 plus st form, 1 plus st form. Okay. Similarly, further simplify, g of s h of s equal to this 2 and this 5, 2 into 5, that is 10. So this 10 in the numerator, this 10 in the denominator cancels. So finally your transfer function becomes only 1 divided by s into 1 plus s by 2 into 1 plus s by 5. So next replace s by j omega. What is that one? G of j omega, h of j omega, this constant term only 1 plus 0 j omega. So here imaginary part is 0, whole divided by, that is s, how you write? 0 plus s, that is 0 plus j omega, replace s by j omega into s 1 plus s by 2, that is 1 plus j omega by 2 into 1 plus j omega by 5. This is little bit lengthy as compared to previous examples. So once again, as usual, find the magnitude ratio, which is given by m omega equal to real square of numerator plus imaginary square of numerator to the power 1 by 2 whole divided by real square of denominator plus imaginary square of denominator to the power 1 by 2. So here 1 square plus 0 square to the power 1 by 2 whole divided by s omega plus 1 square plus omega square by 4 to the power 1 by 2 into 1 plus omega square by 25 to the power 1 by 2. Okay, this is m omega. So once again further simplify, 1 square plus 0 to the power 1 by 2 means only 1, that is omega 1 plus omega square by 4 to the power 1 by 2 into 1 plus omega square by 25 to the power 1 by 2. Call this as equation number S1. Coming to the phase angle, that is phi omega equal to tan inverse of imaginary by real of numerator minus tan inverse of imaginary by real of denominator. So in the numerator only one independent term is there, 1, that is phi omega equal to tan inverse of 0 by 1, imaginary part is S0, real part is 1, minus tan inverse of S, imaginary part is 0, real part is omega, minus tan inverse of imaginary part is omega by 2 and real part is 1, minus tan inverse of omega by 5 divided by real part is 1. So finally tan inverse of 0 is 0, minus tan inverse of anything by 0 is infinity, that is minus 90, tan inverse of omega by 2 as it is, minus tan inverse of omega by 5 as it is. So finally your equation becomes what is that? Yes, tan inverse of 90 minus tan inverse of omega by 2 minus tan inverse of omega by 5, that is called equation number S2. Let us substitute the limiting values of, what is that one? Omega and 0. Let's see, putting the limiting values of omega as 0 and infinity separately. As omega tends to 0, m omega is infinity. Just see here, m omega 1 divided by the omega tends to 0. So here 0 means whole term becomes 0. 1 by 0 is infinity. That we have taken here. 1 by 0 is infinity. And phi omega is minus 90. These two 0. So directly minus 90. So at minus 90, m omega is infinity. Okay. As omega tends to infinity, m omega is omega by omega, that is 1. Just see here, m omega, omega by omega, that is 1 by omega. As omega tends to infinity, m omega is, yes, that is 1. Phi omega is tan inverse of s omega, that is minus 90. Omega is infinity, minus 90. That is infinity, minus 90, plus 90. So plus 90 minus 90, that is 0. If omega tends to 1, once again, m omega is 0. Phi omega is minus 90, minus 90, minus 90, that is 270. That is minus 270. To find the value of omega, where the crossing the imaginary axis, so hence the root locus between minus 90 and 270, that is minus 270, not plus 270. This is minus 70. So hence, so in between it is crossing the real axis, that is 180 degree line. So hence you take to find the omega. What is that one? To find the omega, phi omega equal to minus 180 degree. So equation 2 you can take, phi omega equal to 90 minus tan inverse of omega by 2 minus tan inverse of omega by 5. So phi omega is minus 180 degree, that is minus 180 degree, 90, and this value. So for this, once again you substitute tan inverse of omega by 2 as, we take this side plus tan inverse of omega by 2, so 90 minus this will come this side. Okay, 180 minus this come plus, and this goes, that is plus 90. Okay, let tan inverse of omega by 2 as A and tan inverse of omega by 5 as B. Okay, what will you see? The equation 3 becomes, well, this equation becomes A equal to 90 minus B, that is A equal to 90 minus B. So applying tan function both sides, tan A equal to tan 90 minus B. So change the function because it's 90. So tan 90 minus B means cot B. So tan A equal to cot B. Once again you can write cot B as 1 by tan B. So tan A, tan B this side. So on the right hand side it's become 1, because yes, A equal to tan inverse of omega by 2 and B equal to tan inverse of omega by 5. So tan A, tan B equal to only omega by 2 into omega by 5, that is equal to 1. That is equal to once again omega square by 10, that is equal to 1. So omega equal to the 10 on the right side is become 10 on the right side. It is omega square by 10. 10 this side, omega equal to square root of 10, that is 3.162 radians per second. It is the crossover frequency is 3.162 at 180 degree line. It is crossing to the 180 degree line at radian frequency is 3.162. Okay, substituting equation 1, we have omega equal to 3.16, we have m omega is 0.143 at negative real axis, that is minus 180 degree line. So by taking suitable scale, this magnitude is draw the polar plot. So taking suitable scale, locate this point using the polar coordinates. Okay. Draw the smooth curve passing through all these points obtained to require the polar plot. Okay. Let's see the curve passing through minus 180 degree line. So here, as omega tends to 0, m omega is, that is, what is that one? Infinity. As omega tends to infinity, m omega is 0. As omega tends to s, it is crossing, that is root 10, that is 3 point something, 3.16, this point. With suitable scale, we have 0.1, 0.2 and 0.3. Draw the smooth curve. So it is crossing the negative real axis, that is minus 180 degree line. There the crossover frequency is root 10, that is 3 point, shown here 3.162, that is radians per second. Okay. This is the polar plot for this example. You just see in this example, we are having the order number is 3. So you just multiply the order number by 90 degree, that is 270 degree. So it is starting from minus 270 degree line, and type number is 1 into 90, that is minus 90. So it is ending at this one. So the system type number will tell the starting point, and order number will tell, type number will tell the starting point, order number will tell the ending point. So it will start here, ends there. Okay. In between 90 and minus 270, it is crossing the negative real axis, that is minus 180 degree line. So hence always with the what is that one? The system type number and order number, it will tell the starting point and ending point of the polar plot. So this example is a little bit tricky as compared to other previous examples. Okay. Now let us once again briefly summarize this session. So in this example session, we are having two examples, example number 5, example number 6. So in example number 5, we have observed type number is 1, order number is 1, starting point is into 90, ending point is into 90, starts and ends minus 90. Okay. So this is the polar plot for that transfer function, and this example, it will be tricky. So here type number is 1, order number is 3. It will starts here, ends at 3 into 90, that is minus 270 degree line, 1 into 90, that is minus 90 line, starting from minus 90 ending at minus 270. So in between it is minus 180 degree line. So there it is crossing the imaginary axis. There you have to find the crossover frequency. It is told further, hence determine the frequency and magnitude ratio where the curve crosses the negative real axis, that you can find out. So it is crossing at 3.16, that is root 10, at what is magnitude ratio, that is root 10, crossover frequency is root 10, magnitude ratio is, that is, what is the magnitude ratio you got on that one? Yes, magnitude ratio is 3.162 as omega is this one, that is 0.143. It is crossing the real axis, that is -180 degree line by this much amount, and the frequency is, that is 3.162 radians per second. This is the graph. Okay, with this I conclude this session. Thank you.